Okay, the next component I want to talk about is the location component. This one is pretty easy, and so we'll tackle it next. If we go to the Unity client now, we can see here that I've used a more standard naming convention for some of our components than we used in our last assignment. In particular, I mean that I capitalized the first letter of these game objects, and then there's a class and a script associated with each of them that has the same name with a capital first letter indicating it's a class. The reason why I put my GUI and why I put the word my in front of GUI in this case is because GUI is a reserved word in Unity, and because these are pretty common words, they'll often be overloaded in the Unity game engine. So by putting the word my in front of it, we ensure that we're using something, well, we're not sure of it, I guess, but it's a better chance that we're not going to be overwriting something important in the game. So let's start with taking a look at this location component. If you remember, having something in the hierarchy here means that it is a game element, and so for a game object, I'm sorry. So to create a holder for MyLocation, you'll go under game object and create an empty game object. That'll pop up here, and you'll have to name it. You can name it whatever you want, but you're going to have to remember the name at the appropriate times in order to access it. So the name is here, MyLocation, and oops, what did I do there? Change something? Okay, good, MyLocation. And what I did is I added a component, I added a script, and this is a C# script, and it's one that's provided for you. So let's go ahead and take a look at it and see what it does. Notice here that there's this button for mock locations. Keep that in mind. Okay. Here we have, let's see, I'm trying to get it so we can see the screen here. Here we have the code associated with the MyLocation element. It starts with the standard library inclusions that come with that are required for C#. And then we have this. We have a couple private variables. We have a private Boolean variable called working that says whether or not the location services are working. We have three private floats for the latitude, longitude, and altitude. These are where we're going to keep track of the most recent position that we've received, but they're private. We're not going to let anyone else have access to them except through our getters and setters. Here we have a new section that we didn't have before. This is a mock location section. Because it's kind of hard to debug by going out and walking around, what this does is when mock locations is set to true, either here in code or here when you click it on, in fact it has to be clicked here because it'll override whatever the script says. So if you click it here, it'll be true when you run it. If mock locations is true, then what happens is that the game engine will simulate movement from the northeast corner to the southwest of the corner from a low altitude to a high altitude over a span of several seconds, and those locations can be specified here if you would like to do mock location. So that will allow you to walk on one path for a period of time so that you can debug things in your game engine. Okay, the next section here is a Haversine class. Haversine is just a way of determining distances between latitude and longitudes. This is used internally for calculating the distance between latitude and longitudes. Then here are some getters that are available for the rest of the code, in particular your GUI code, in order to get the latitude and longitude that the game engine has. Here we have the standard start method that's called by Unity when this class is initialized, and what this start method is going to do is start the location services. Provided that location has been enabled by the user in the phone, we're going to start getting location. This is where we have when we specify how high accuracy we want, and that in turn causes Unity to turn on different location technologies in the phone when it becomes appropriate. So by setting it to one floating point and one floating point, that says we want 1 meter accuracy and we want to be notified if the position changes more than 1 meter. We wait 20 seconds for everything to initialize. If it doesn't, then we fail. Otherwise, we set working to true and we return. And then periodically, the update function, which is called by Unity in this class, will do the following. If the location services are working after we did our start function, Then, if we are faking our locations, then we're going to run a little bit of code here that causes our locations to change over a period of time. If we're not faking our locations, then we're going to update our current latitude and longitude, our locally stored latitude and longitude, with whatever the system says. So if there's been a change indicated here, let's update our stored latitude and longitude. And then if anyone wants to access it, they can call the public getters getLatitude and getLongitude. Okay, so that's all that there is to the location component. We go back to our Unity script. You see that our location component here connects to that script. That script has to be located somewhere in your assets folder. And then where are you going to get that from? Well, that's available online. It's available from a GitHub repository. There is a link on the assignment page that links directly to it. But if you would like to find it online, you can do that by going to the project TerraTower. DJP3 is me. So if you search for TerraTower, if you search all repositories for TerraTower, you'll get the repository. And then because this code is still on a branch, we're using the branch version 001 for this tutorial, for this section, for this assignment. If you go into the Unity TerraTower client, look at the assets, you can see that MyLocation C# is there. And if you want to grab it, you can just grab it by clicking raw and cutting and pasting that. Okay, so that's how you put location into our TerraTower client. The next thing that we'll cover is how to get a gyroscopic camera. And before that, we'll need to talk a little bit about the world. Okay, thanks.